Alright, hi students. So this is going to be a really quick video. I just want to help you on the IXL problems that I saw students having trouble with. So remember yesterday you were supposed to do IXL skill J.1 and I.2, and I've been giving credit to the students who have completed or mastered those skills. So if you haven't done them yet, please go on to IXL and complete those two skills. Alright, so hopefully this video helps clarify any questions you got stuck on for IXL. I know a lot of kids got stuck and couldn't finish yesterday, so I'm gonna hopefully show you through this video how to do those problems. So before we go on to the problems, let me just remind you that temperature is different from thermal energy. Okay, temperature is different from thermal energy. Those are two different things. So temperature is what we measure using a thermometer. Temperature is the average. It's the average amount of kinetic energy of the particles. So for example, say that there's 20 particles in here, and these 20 particles are all moving kind of slowly. Their kinetic energy is low. So on average, these particles have a low temperature. And now let's look at this one. Say that there's 20 particles in here and they're all moving pretty fast. So on average, they have a high temperature because on average, their kinetic energy is pretty fast. It's high. Now, thermal energy is different from temperature. Thermal energy is the total amount of kinetic energy of all the particles. So, like in this example, there are less particles of orange juice in this small container. See that there's 30 particles of orange juice in here. And if those particles are all moving around the same speed, even in this carton, then the temperature will be the same. So the temperature is still 40 degrees because they're all on average moving at the same speed. However, this small orange bottle has less thermal energy because there's less particles in here. So there's only, say, 30 particles. So no matter how fast those particles are moving, in total, it's going to be a smaller number compared to this one where there might be 1,000 particles. So this orange juice container has more thermal energy because there's more particles in here. It has a bigger mass. It has more matter. It has more particles. Okay? So thermal energy versus temperature. Again, we have a small cup of hot chocolate and a large pot of hot chocolate. So if you think about the little particles in here, the particles on average are all moving pretty fast. So it doesn't matter the size. The temperature of this cup of hot chocolate and the temperature of this large pot will be the same. It'll be around 100 degrees because they're moving on average at the same speed. However, there's way more particles in this big, large pot. So if you add up the kinetic energy of every single particle in this pot, it's going to be a bigger number. So that's why the large pot of hot chocolate has more thermal energy than this little cup. Okay? All right. Now, this is an example from the IXL question you had. So imagine you have 3 cups of hot chocolate and they're all the same size and there's the same amount of liquid in each one. Okay, they're all equal amounts. So each of these cups of hot chocolate are 100 degrees Fahrenheit. The particles are moving pretty fast and on average they're all 100 degrees. That's the temperature. Now notice, if I combine all 3 cups, if I pour all 3 cups of hot chocolate into this large pot right over here, the temperature will not change. It's still going to be 100 degrees. However, what changes? Well, the thermal energy changes. The thermal energy of this pot is going to be 3 times the thermal energy of each individual cup because see that this cup's thermal energy is going to combine with this one and this one. So now this pot of hot chocolate has 3 times the amount of thermal energy of each individual cup. Because imagine how you're combining 3 containers with all these particles all together. So now the thermal energy goes up by 3 times. So I'm going to show you the IXL question. So this was IXL question I.2. So if you look over here, it says missed questions from this type. 3 cups of tea have the same mass and temperature. It's just like the hot chocolate question. And they're combined into one large pot. Now the large pot has the same temperature as the small cups. And the larger pot of tea, again, has the same temperature as the original cups of tea. However, the amount of thermal energy in the larger pot is going to be 3 times the amount of thermal energy in each of the smaller cups because it's 3 times the size. Okay? Now, same for this one. Or this is going to talk about temperature, so let me show you a different slide over here. Now, imagine you have a pear, one pear, and it's 80 degrees Fahrenheit. If you cut this pear in half, remember the size, if the size changes, that doesn't matter for the temperature. The temperature is still going to be the same. So even if you cut a fruit in half, each piece has the same temperature as the original pear. However, since you cut it in half, thermal energy depends on the mass, how much particles there are. So if you cut the pear in half, now each slice is going to have 1/2 the amount of thermal energy in the original pear. Because these 2 slices have 1/2 the amount of particles as this big pear. So thermal energy will change based on the mass, how much particles there are, how big the size of the object is. However, the temperature is the average kinetic energy of the particles, so it does not change based on size. Even if it's smaller, the temperature does not change because it's just measuring on average how fast the particles are moving. So let's look at this question. This is the same one. A pear is cut into 2 pieces. The amount of thermal energy in each piece is about 1/2 the amount of thermal energy in the original pear. Okay, I'm going to do just one more for you. Say that you have 4 bottles of corn oil. They're combined into one large bowl. And it says the temperature of the larger bowl is about blank the temperature of the original bottles of corn. So let's think back to the hot chocolate. If you combine these 3 cups of hot chocolate into a large pot, what's the temperature going to be? Well, the temperature is not going to change. It's going to be the same because temperature does not matter the size. So the temperature of the larger bowl of corn oil is about the same as the original bottles because temperature does not matter. It does not matter or depend on the size or the amount of mass there is. Okay? All right. So hopefully that helps you figure out these questions for I.2. Now I'm going to go over, let's see. Let me go over at the top this one. So it says the kinetic energy of a ball or any other object depends on its mass and speed. The same is true of the kinetic energy of a particle. So if there's more mass a particle has, and the lower the particle speed, the less kinetic energy the particle has, well, you're going to have to change these blue words to make it correct. Remember, the kinetic energy depends on how fast the particles are moving. So if the particles are moving fast, then there's going to be more kinetic energy. Okay, but it does not matter how many particles there are, it's about how fast they're moving. Okay, now this one, it says, select all that's true about the rubber ball shown above. The kinetic energies of the particles in the ball determine its temperature. Now that's true because temperature depends on how fast the particles are moving. It's measuring the kinetic energy. And it says if the ball is hot, its particles tend to have a small amount of kinetic energy. This one's false because if the ball is hot, that means that the particles are moving very, very quickly. And this one says even when the ball is not moving, the particles that make up the ball are still moving. Now that's true because even if the ball isn't moving, there are small particles inside the ball that are still vibrating side to side. Okay? All right, I think that should be fine. Hopefully this helps you with your IXL problems. If you need more help on a specific question, you can message me on Schoology. I'm gonna post these slides along with this video so you can take a look at these. This is your hint right here, okay? This box is your hint. So use this to help you with your IXL problems. All right, please get those done today. I want to see more people who have completed or mastered those two skills. And if you still have not done Wednesday's assignment, you have to message me on Schoology, the secret word, and that's how I will, once I get your message, I'm gonna assign the homework to you. So once I receive your message, for example, I would go to the homework, which is this green puzzle piece. You can't see this until I've received your secret word message. So those of you who have not done Wednesday's homework, please message me soon. All right, have a good rest of your day. Thank you for watching.